Welcome everyone. We are delighted to have you all here for this informative session on integrating Amazon RDS Oracle with Amazon Elastic File System EFS. In this session, we aim to share with you how to integrate EFS with RDS Oracle and what are its benefits. We will also provide you with a quick demo on how to do it. My name is Javed Mohammed and I'm a database solutions architect at Amazon. I'm joined by my colleagues Vishal and Sharath, who will be co-presenting various segments of this session alongside me. Without further delay, let us dive into the world of RDS EFS integration and explore how this integration works and the benefits that it has got to offer. The agenda for today's session is as follows: introduction to Amazon RDS for Oracle and Amazon EFS, overview of various data movement options available when migrating databases to Amazon RDS for Oracle, understanding of how the integration of Amazon EFS with Amazon RDS for Oracle can simplify the database migration process, a step-by-step guide on integrating Amazon EFS with Amazon RDS for Oracle, along with a demo. Let's begin by exploring what is Amazon RDS for Oracle. To begin with, a brief introduction of RDS. Amazon Relational Database Service RDS was built by AWS as a way to help customers reduce the complexity in supporting critical transactional applications by making it easy to set up, operate, and scale a relational database in the cloud. RDS automates time-consuming administration tasks such as hardware provisioning, database setup, patching, and backups while providing cost-efficient and resizable capacity. RDS makes your databases available and durable by supporting options such as multi-AZ data replication, automated backups, and snapshots. RDS makes your databases more performant and scalable by supporting scale compute and storage within just a few clicks with minimal downtime for your application. Furthermore, RDS makes your databases more secure and compliant by supporting data encryption at rest and in transit. RDS is currently offered for 6 familiar database engines, that is MySQL, PostgreSQL, MariaDB, SQL Server, Oracle, and Amazon Aurora, which is compatible with MySQL and PostgreSQL. In a nutshell, RDS provides customers with lower total cost of ownership, easier management, so that they can focus on the things that matter for their business and applications. Now, let's talk about what is Amazon Elastic File System. Amazon Elastic File System EFS provides serverless, fully elastic file storage so that you can share file data without provisioning or managing storage capacity and performance. Amazon EFS is designed to provide secure access for thousands of connections for Amazon Elastic Compute Cloud EC2 instances as well as AWS container and serverless compute services. Amazon EFS also simultaneously supports on-premises servers using a traditional file permissions model, file locking, and hierarchical directory structure through the NFS v4 protocol. Amazon EFS is built to scale on demand to petabytes without disrupting applications, growing and shrinking automatically as you add and remove files. With Amazon EFS, you pay only for the storage used by your file system, and there is no minimum fee or setup cost. Because Amazon EFS has a simple web services interface, you can create and configure file systems quickly and easily. The service manages all the file storage infrastructure for you, meaning that you can avoid the complexity of deploying, patching, and maintaining complex file system configurations. Amazon EFS is designed for 11 nines of durability and up to 4 nines of availability. EFS is also performant and designed to provide the throughput, IOPS, and low latency necessary for a broad range of workloads. EFS is cost optimized. EFS provides 4 storage classes with different price and performance characteristics. It comes with automatic lifecycle management to transition infrequently accessed files to lower cost infrequent access storage classes, and it offers intelligent tiering to optimize cost for use cases with variable access patterns. Now let's talk about the use cases of Amazon EFS. EFS is designed to serve the vast majority of file-based workloads covering a wide spectrum of performance needs. These range from single-threaded, latency-sensitive workloads such as developer productivity tools to highly parallelized, scale-out jobs requiring high throughput like big data and machine learning applications and everything in between. Some of the most common use cases of Amazon EFS include simplification and centralization of DevOps, which includes CI/CD pipelines, code repositories, and issue tracking. Common applications in this category includes Jenkins, Confluence, and Git. Next, we have web serving and content management, which involves creation and modification of digital web content. Then we have data science and analytics. EFS enables customers to accelerate data insights, machine learning training, inference, and analysis. Next, we have media processing, which includes image processing and video hosting. EFS is also used as secondary storage to store backups for databases like Oracle, Cassandra, and MongoDB. Last, and certainly not the least, EFS is used in modern application development. It allows customers to build new cloud-native applications and migrate custom enterprise applications without any re-architecture and modernize at your own pace. Now, let's talk about data movement options with RDS Oracle. Here, we will talk about new option of EFS integration with Amazon RDS for Oracle. There are several options for data movement into RDS for Oracle instance. We can move the data from source database, which could be on-prem Oracle database, or RDS Oracle database, or Oracle database on EC2, to target database, that is RDS Oracle, using different ways like DB links over the network, logical replication using tools like DMS or Golden Gate, bulk load using data pump, etc. We typically use data pump with S3 integration option, and the steps involved with this approach are: initially, we take an export backup of source database using data pump. The backup dump file is then copied to S3 bucket. The next step involves downloading the backup dump file from S3 bucket to RDS Oracle instance where we intend to import the data. And then we finally perform an import. These dump files occupy storage space on the RDS Oracle instance itself. For example, if you have a 1 terabyte dump file that needs to be loaded into your instance, you need to create a 2 terabyte RDS Oracle instance. This allows you to stage that 1 terabyte dump file, load it into a terabyte of table spaces, and then subsequently drop that 1 terabyte dump file. As a result, you will have a terabyte of space that may not be immediately reusable, as we may not have a need for it. And also we cannot shrink the allocated storage in RDS Oracle. When you get to larger sizes, especially with large database migrations, it can really add up and customers end up paying for the extra unused storage from the moment it is allocated. With EFS integration option, you can stage transitory files like Oracle Data Pump export files on EFS file system and directly import from it. It offers faster migration of data as compared to migration over database link. You can use Amazon EFS file system mounted on Amazon RDS for Oracle database instances as a landing zone for various Oracle files required for migration or data transfer. Using it as a landing zone helps to save the allocation of extra storage space on the Amazon RDS instance to hold the files. You can also mount an EFS file system directly to an on-premise server as a further means to simplify the migration process. The Amazon EFS file system can automatically scale from gigabytes to petabytes of data without needing to provision storage. There are no minimum fees or setup costs, and you pay only for what you use. Amazon RDS for Oracle with Amazon EFS is well suited to support a broad spectrum of use cases, such as share a file system between applications and multiple database servers, use it as an upload location for the native dumps and backups required for migration, store and share RMAN backup and recovery logs without allocation of additional storage space on the server, use Oracle utilities such as util_file to read and write files. Now I will hand over to Vishal to walk us through the steps to integrate EFS with Amazon RDS for Oracle.
Hello everyone and welcome to this part of the video. My name is Vishal Patil and I'm Database Specialist Solutions Architect at Amazon. In this part, I will be presenting on how to integrate EFS with your RDS Oracle instance for data movement. The goal of this presentation is to walk you through every step of the EFS integration process. By the end of this video, you will have a better understanding of what all steps are required to configure EFS integration with RDS Oracle. Let's get started. First step is making sure that your RDS for Oracle instance has an IAM role which will allow it to access EFS file system later on. In this, we will create an IAM role and associate this newly created IAM role to your RDS for Oracle instance. Next step is to create EFS file system if it is not already created and update its security policy to allow access to the IAM role we created in last step. This is to make sure RDS Oracle instance has permissions on the EFS file system. We use standard or standard IA storage class to create the file system. We would create the mount targets in respective availability zones. We also update the policy to allow access for newly created IAM role. In this step, we will mount the EFS file system on an EC2 instance to grant permissions for other users. By default, only root user has privileges on the file system. Before we can mount the file system in an EC2 instance, we have to update the mount target security group to add an inbound rule to allow access on port 2049. The source will be EC2 security group. After mounting the EFS file system on an EC2 instance, change permissions for the file system to 777 so that other users like Oracle installation user on RDS Oracle will be able to read-write files from this EFS file system. Next step is to enable EFS integration option in an option group of RDS Oracle instance. First, we need to create an option group with the option EFS_integration. While adding the option, we need to specify EFS file system ID. Second, we will need to modify RDS Oracle instance to use new option group which has EFS_integration included. Third, we will want to make sure the security group of mount target is updated to allow inbound access on port 2049 from RDS Oracle instance using RDS Oracle security group as source. Lastly, to access EFS file system from RDS Oracle instance, we will create a directory object using RDS admin util package under RDS admin schema, and the procedure is create directory EFS with EFS ID in the path for EFS attribute. This concludes all the steps required to configure EFS integration with RDS Oracle instance. Now I will hand it over to Sharath for a demonstration of these steps.
Thank you, Vishal. Hello all, I am Sharath Chandra Kampili, a database specialist solution architect here at the AWS office in Dallas. Today, I am going to show you how you can integrate EFS file system with RDS Oracle and also do a sample migration using Datapump. Let's get started. As a part of EFS integration, we have to configure IAM permissions for RDS for Oracle integration with Amazon EFS. Now, let's create an IAM role for the DB instance. Let's go to the IAM management console. In the left navigation pane, choose roles and then click on create role. For AWS service, choose RDS from the bottom of use cases for the different services and then select the choose RDS add role to database as we associate this IAM role to the Oracle DB instance. Then click on next. And here don't add any permissions or policies, just choose next. Set role name to a name of your IAM role. For example, RDS EFS-integration-role, and you can leave the description as it is and then click on create role. Once the role is created, search for the role and then copy the ARN for your future use. Next, to associate your IAM role with your RDS instance, please go to RDS console, select the RDS instance, click on the Oracle DB instance, and on the Connectivity and Security tab, scroll down to the Manage IAM Role section at the bottom of the page. Choose the role to add into the IAM roles you created previously. For feature, choose EFS integration and then click on Add Role. You can see the role is active. Next, to create a EFS file system, you can configure the file system policy and the network settings at the same time by using the Customize button. Now let's go to the EFS service on console. Click on Create File System. And here you can provide the name of your EFS file system. As an example, RDS EFS integration. Choose your VPC. Then click on Customize. And here we will be leaving all the options as it is. Click on Next. And here we have already automatically selected the availability zone, and we can add the add mount target for the new availability zone, and the subnets are also automatically selected. And here if you want to change your security groups, we can change to the appropriate one. Here I am changing to the appropriate one and then clicking on Next. To grant the additional permissions, you can click on that and then click on Add, and here you will be providing the IAM role that you created previously, and then you will change the permissions to read, write and root access, and you will be seeing the IAM role here. Click on Next, and you can review all the options that you have provided previously for this file system. And once you confirm, you can go scroll down, click on Create, and the file system will take a couple of seconds to be in available state. And here you can see the file system is in available state. Next, to enable the EFS integration, we need to create a custom option group and add EFS integration option to that option group. Let's go to RDS service, choose option group on the left navigation pane and click on Create Group. Here you can provide the name. Here I am providing RDS EFS integration -option -group, and you can also provide the description. Right now I'm just copying the same description as it is, and you can choose the engine as Oracle Enterprise Edition, major engine version as 19C, and then click on Create. And you can click on View Option Group to add an option. Scroll down to the page where you can see Add Option. Click on Add Option. Option name as EFS Integration. Then we have to provide EFS ID, the file system ID that you have created previously, and then use IAM role, leave it as it is, and then click on Yes or Apply immediately. Click on Add Option. You can verify by clicking on the V option group, and you can see the EFS integration option has been added. Now we have to change or modify the RDS instance with the option group. Here I've already modified the RDS instance with a new option group. You can go to the configuration and check the new option has been populated and it's in sync. Next, to mount the EFS on EC2 instance, as a prerequisite, we need to install the NFS utils on the EC2 instance and also grant necessary permissions to EC2 instance role. Now let's go to the EC2 instance and do a df-h to see the directory structure. And now let's create a directory using mkdir, and here we'll be creating /EFS directory. Now let's mount the EFS. In order to get the mount command, you can go to the EFS file system, which is EFS service, and click on attach. You'll be seeing the mount command that you're showing on the screen. And then you can paste that command here on the EC2 instance. Then click on enter and do a df-h to see the file system. And here you can see the EFS file system has been successfully mounted. Please note, you need to add the file system information into /etc/fs tab to have the file system persistent across reboots. Now let's perform a sample migration using data pump on EFS instance. Firstly, let's go to the prerequisites. We have an Oracle database on EC2 instance simulating as on-prem database. Please do a ps-ef pmon to see whether the database is up and running. Now you can see ORCL is up and running. And also we created a RDS Oracle database for this demo. Log into the database using SQL plus SysDBA. Now let's create a directory for the export job. And here we are creating a directory exptp underscore source.db. And also we grant necessary permissions to the particular directory, to the HR schema. Now let's run the export dump file to take the backup of the schema HR. And you can see the export job has been successfully completed. And also you can verify the export dump files on the EFS file system. Here you can see the dump file and the log file. Now let's perform an import on the RDS instance. Log into the RDS instance using SQL plus and check for the db underscore directories to see if the /EFS directory is already created. And here we can see there is no /EFS directory created. Now let's create a directory on the RDS database to mount the EFS on RDS. We have created successfully. And then you can list the directory by using this command. And you can see the dump files are existing in this particular EFS directory. Now let's verify the data on the schema HR in the RDS instance. You can see no objects created. Now let's run the input command to migrate the data from on-prem to RDS using EFS. And you can see the job has been successfully completed. And now let's verify by logging into the RDS. Let's verify the objects for the HR. And you can see there are different objects has been migrated successfully. Please note, you can mount the same EFS file system anywhere if you want to access the dump files. Now you have successfully migrated the sample data using EFS from EC2 Oracle database to RDS Oracle database. Thanks for watching and happy cloud computing from all of us here at AWS. Thank you.